All right. This is the debate: is ancestral health a useful or terrible heuristic? In the description, I have that I say it's useful. Nick Hiebert, the Nutrivore, says it's terrible. Nick will be coming on soon. And through private discussion, I believe we will wind up revising the proposition somewhat to the point where we each think there is some usefulness and some limitations. We will probably debate what that usefulness is or what those limitations are and how useful it is. But we'll see. So, see, I'm inviting Nick to or invite to send co-host Nick, and we'll see when Nick gets on. So I think that the format that we're going to follow will be, we will allow some questions at the end, but we will discuss this. Nick's here. Okay, cool. So we'll probably do something like 45 or 50-minute discussion followed by 10 or 15 minutes of questions from listeners after the fact, but we'll see how it goes. Nick, I think that, given our discussion, given that I originally derived the title for this from the tweet that you wrote. I'm not sure how much we disagree within the domain of things about which I hold strong opinions, maybe about the value of ancestral diets for health. I think ancestral diets for health is a fucking terrible heuristic that is inherently prone to failure. And then through private discussion, it sounded like maybe you think that the heuristic is actually useful, and so do I, but we'll disagree on the specifics. I guess the best way to start would be if you could kind of clarify what your position on what the usefulness is and where its limitations are. But I think both of us, when we state our positions, should also define what we mean by the ancestral diet for health heuristic, because you and I might have somewhat different definitions of it. So why don't you take the floor and state your position as well as your definition of that heuristic?
Yeah, I think we both have a little bit of clarifying to do. So when we say that an ancestral diet or an ancestral health heuristic is either good or bad, useful or useless, those concepts only make sense relationally. They're relational concepts. So, like, you might say that an ancestral diet is a useful heuristic. I made the mistake of not clarifying myself, right? I said that an ancestral diet or an ancestral health heuristic is terrible. And I think we both made a little bit of an error right there, because these concepts only make sense relationally. They're relative concepts. So if the proposition is that an ancestral diet heuristic is superior to, say, a standard Western diet and lifestyle, for example, then there's no disagreement between us. It would be superior in that regard. However, I take the position that there is a subset of unnatural diets that would be superior to an ancestral diet. So compared to a certain subset of unnatural diets, an ancestral diet heuristic would actually be suboptimal or inferior.
All right. So my position is that ancestral health could basically be subdivided towards insights that could be gained through ancestral restraints and insights that could be gained through the body of ancestral accumulated knowledge or wisdom. And so in the former case, that's saying something like, I would hypothesize that that artificial lighting is bad for human health in certain ways. And I'm drawing this from the fact that ancestrally, we always had the restraint that we were exposed to a certain spectrum of light starting in the morning that then consistently and systematically operated on some transition to higher blues and then lower warm light and then darkness at night. And then, but that also, would have obvious downsides, because we could say humans never before had electricity, therefore using electricity is intrinsically bad for your health. And that would, maybe you can justify that with some sort of EMF exposure related hypothesis, but that, we wouldn't be on Twitter if we agreed with that. I think so. I think that has a certain usefulness. I'm not sure how to quantify it, but I do think that, compared to randomly generating ideas that have no basis, if I come up with a random idea generator, I don't know how often the ancestral restraint is going to generate a true idea, but it's going to be more often than a randomly generated idea. But I think there's going to be higher success with ancestral wisdom, or ancestral, the accumulated body of knowledge or body of thought within our ancestors. I think a good example of that would be how if Europeans had taken corn from the Mesoamerican natives and also taken the tradition that came with it and nixtamalizing it, we might have never had the pellagra epidemic. That's not to say that every piece of knowledge that came from our ancestors is true. That would be absurd. But I think that if you take, and the reason for this is that there is an accumulated body of knowledge within our ancestors collectively that came from trial and error and experience, and there is some selectivity on the evolution of those ideas, such that if the accumulated body of knowledge is net on average bad and harmful, you are going to have some kind of group selection effect, just mediated not through actually the evolution of genes, but just the evolution of ideas and culture. And I also think that also, one of the things that might come up in this debate is that evolution selecting genetics is not necessarily going to lead, or almost certainly does not lead to perfection, and will have some downsides with respect to longevity. But on the other hand, the accumulated body of how to eat and how to live, especially as it comes from groups of ancestors that have track records of long ancestry, probably is on average, a more beneficial source of information than starting from randomly generated ideas. And so, and I think that's my position, that there is value in, and I guess I'll comment on your conclusion. So about the artificial diet. So I'm not even actually that interested in artificial diets, and so I don't have like a developed body of thought specifically on the future of artificial diets, because I'm much more interested in eating a natural diet. However, my and I don't think we actually know this yet. So I would agree with you that in principle there should be such a thing as an artificial diet once our accumulated knowledge of nutritional science is good enough to make that diet. However, I think the optimal, well, let me say this. So I believe that there's no such thing as an optimal diet, that each person probably has a diet that's optimal for themselves based on their unique genetics and circumstances, et cetera. And that what diet is optimal for a person probably varies over time with life changes. So it's different for when you're a child, it's different when you're a man versus a woman, it's different when you're menstruating versus before versus after, it's different when you're pregnant, when you're lactating, and then we could throw in 1,000 other contextual factors. And that if you just collectively, if you somehow knew what the optimal diet for each person was at each life stage and you just aggregated them, you would have some spectrum of optimal diets. And I think that would almost completely overlap with the range of ancestral diets. But there would be some exceptions, So, and that's because there are, let's take someone who just has a genetic disorder that maybe is fixed by or is ameliorated by a high dose of a vitamin that you could never get from food. That person's optimal diet is probably something from the range of ancestral diets, then with supplements of that vitamin that they could never get from that food, and that's artificial in a particular way, in a very narrow and specific way, but that artificial thing is what optimizes the diet for that person. As to whether we could start from scratch and make an artificial diet that is superior to anything in the range of ancestral diets, in principle it should be true. But I think if we learn, if we want to look forward and expect the have an expectation for the range of hurdles we would face in doing something like that, then I think that history with doing the same exact thing for lab diets with rats, doing the same thing for total parenteral nutrition for humans, doing the same thing with infant formula. Basically, we have numerous examples where we've tried to make a perfect diet based on current knowledge that were all rather disastrous for long periods of time, where it took many decades and much suffering to come up with the knowledge of why what we did wrong was wrong at that time. And so I would expect something very similar, where it would take, if we're going to try to start artificial diets, it's going to take us a very long time to know, and because knowledge is better now than at any given time in the three examples I just gave, we probably won't make the same errors again. And so we'll have a limited scope of the type of errors that we can have. And probably the downside risk is less bad than it was when we had less knowledge. But there's still going to be, I would expect, tons of downside risk with doing, more harm than good for quite a long time before we would ever arrive at that optimal artificial diet. And I think it would be very hard to know when we're there, just due to how long it would take to understand the effects of a new anything over a lifetime. So that's my position on that. And I guess at this point, maybe each of us could take turns, over kind of justifying our position with more detail. But any thoughts on what I said, or would you like to just kind of lay out your framework in more detailed evidence?
Well, okay. So you said something at the beginning about how, since humans were exposed to, natural light, you would infer from there that it's probably likely to be the case somehow that artificial light would be bad. I would actually just straight up reject that. Because if you have a genuinely novel exposure, the principle of indifference would apply. And you actually, since you have no priors on it, it would make no sense to actually form a belief one way or the other about it. So honestly, it's a coin toss. It would be 50-50. Epistemically, it would be 50-50 whether or not artificial light would be better, because you could argue it for being better. Like, maybe artificial light is better.
Well, let me just clarify what I had said. I don't know if I would say it's likely to be true. What I said is that insight would be looking at the ancestral restraints would be a better source of insights than random. And I think you do disagree with that, but I just want to clarify, because I didn't say that would be likely to be true.
Well, no, yeah. I mean, okay, so I don't even think that would hold true as a heuristic, but going off on that would probably be somewhat tangential to what we're talking about anyway. So my primary position is that, so my primary position is that a food or a diet being ancestral is reason enough to be suspicious of its long-term health value. I remember I had sent you a bunch of inferences that I had written down prior to this debate. I don't know if you read them or not, but
I don't even remember you sending them, so I don't think I read them.
Oh, okay, yeah. So adaptations tend to have this quality called antagonistic pleiotropy, where the adaptation is affecting both short-term health and long-term health differently. So antagonistic pleiotropy works by trading off long-term health for short-term reproductive success. And this is a ubiquitous characteristic of adaptations. There's examples of it pretty much ubiquitously in the human body. There's examples of it in nature. So we have a prior about antagonistic pleiotropy being the case more often than it isn't the case. And we know it trades long-term health for short-term reproductive success. So
can you just clarify whether you're talking about a gene versus an idea versus a food versus an environmental restraint?
So anything that would interact with our adaptations, right? Like adaptations, like they're genetic, but they can be constellations of genes. They could be morphological characteristics. They could be behaviors. Pretty much anything that is adaptive and a product of natural selection would be subject to antagonistic pleiotropy. Like those types of adaptations belong to the domain of things that can be antagonistically pleiotropic. So if we're talking about foods, so the more adaptations we have to a particular food, the more likely it is that that food is going to interact with pathways that are antagonistically pleiotropic. And that actually means that ancestral foods are risky in a way that novel foods literally can't be, because they do not belong to that domain. They don't belong to the domain of things that can be antagonistically pleiotropic. So we know that antagonistic pleiotropy is ubiquitous. We know it happens more often than it doesn't happen. And this means that if we were to actually find novel foods that had equal thriving potential in the reproductive window, we could infer from that they would probably be superior to ancestral foods in the post-reproductive window. Because in the post-reproductive window, the chances of that food being negative are higher than 50-50. And because of the principle of indifference, we would infer that the novel food has a 50-50 chance of being either beneficial or detrimental in the post-reproductive window. So from this, we could actually very easily find examples of foods that are non-inferior to, like novel foods that are non-inferior to ancestral foods in the reproductive window, and we just infer from there that they're likely superior to the ancestral foods in the post-reproductive window. And I syllogize it for you. Don't know if you're interested in hearing it, but like the syllogism is basically, if a given novel food has non-inferior health value to a given ancestral food in the reproductive window, then such a novel food is likely to be superior to such an ancestral food in the post-reproductive window. And again, just to reiterate, novel foods don't have this quality of being antagonistically pleiotropic. They can't, because we did not evolve consuming them. So there's another inference. If humans have more genetic adaptations to ancestral foods than novel foods, then antagonistic pleiotropy is more of a concern for ancestral foods than novel foods. Basically meaning that ancestral foods belong to a specific domain that has baked into the cake inherent risks that novel foods don't have, right? So again, like if we find non-inferior foods in the reproductive window, we can infer that they're better in the post-reproductive window compared to ancestral foods.
Could you give like one example of how you would see an ancestral food interacting with a known established example of antagonistic pleiotropy?
I don't think I need to. That's not required in order for the inference to go through.
I think that I think.
But yes, I can. I can
clarify the position because it seems simple.
I definitely can.
Sure, but just to give you why I want you to, it seems to me that antagonistic pleiotropy is a principle that is acting on the selection of genes, and there's not a one-to-one correspondence of foods aren't a genetic trait on which.
Wait. They're not acting on adaptations. They're a product of adaptations.
The selection is acting on the traits, right?
The selection is acting on the traits. Could you clarify what you mean by that?
Evolutionary selection acts on traits, on traits that are rooted in genetics, or acts on.
It produces traits. That's true.
What would you say natural selection acts on? Would you say genetic genes? Do you want to put it that way?
Yeah. Okay, that's fine.
So I'll agree with that. I'll agree with that. So ancestral foods aren't genes. Right. So
yeah, that's fine, but they activate genes.
Right, but they're the environment. Like the ancestral diet is the environment.
The environment activates genes. I don't see how this is relevant.
I think it's completely relevant because natural selection doesn't select the environment; it selects the genes.
Yeah, exactly. That's part of my point. That's baked into my point.
Yeah, but it's so even if you were to say that antagonistic pleiotropy is true of more examples of selection than not, it doesn't follow from that the same proportion of foods in the ancestral diet are interacting with antagonistic pleiotropy more often than not. I mean, just because
Why not?
Because there's nothing about the principle that makes the environment necessarily have an interactive effect. I mean, it's, it could be the case.
Wait. I mean, okay, so genes are interacting with the environment, and most genes have this property. So I don't see what the problem is.
The problem is that the selection is not acting on the environment, and there's not necessarily an environmental interaction with the gene.
It doesn't have to. It doesn't have to.
This is where I think we see this difference. So that's why I think it would be helpful to talk about a specific example.
Yeah, okay. I mean, I can give you a particular example. So, I mean, it's ubiquitously documented in the literature that red meat increases ApoB-containing lipoproteins. ApoB-containing lipoproteins are a necessary component of lipoprotein metabolism, of course. They're important in the reproductive window for maintaining the health of your liver. You need to delipidate the liver. You need to get triglycerides out of the liver. You need to transport triglycerides to peripheral tissues. And that's all well and great. And that keeps you alive, right? And keeps you from getting liver cirrhosis by the time you're 5 years old. The thing is that it also has this downstream effect of producing LDL particles, which increase your risk of heart disease. So the red meat within the context of an ancestral diet is activating an antagonistically pleiotropic pathway. It's trading long-term health for short-term reproductive success. That's a real-world example that's actually really well documented.
All right. I don't want to get into the weeds on any of our disagreements on the effects of red meat. I'm sure we could talk about that for an hour or two, and we would find maybe 50 or 60% agreement on that. But I guess your contention, right, is that red meat, because the spectrum of ancestral foods are more likely to be net beneficial to longevity in those trade-offs than what?
No, it's just that if we have adaptations to particular foods, like some amount of adaptations need to be defended in order for something to qualify as a food, right? Like some amount of gene activation needs to be defended, but the more adaptations that we have to a particular food,
ergo, that ApoB-containing lipoproteins are an adaptation to any specific food.
No, not any specific food necessarily, but it is something that is activated by that ancestral food, which is the point, right? Like we have an adaptation. It's not an adaptation necessarily to a particular food, but it's an adaptation to a constituent of that food, which is found in multiple foods, which we have adaptations to it because we encountered it within an evolutionary context.
But the trade-off, right, is that because there are, I think so if we look at why we want ApoB-containing lipoproteins, that's a little bit different than why we would want higher than normal or higher levels of lipoproteins than what is consistent with cardiovascular health. I think if we just look at why they exist, this has nothing whatsoever to do with red meat at all. They exist to carry fat-soluble nutrients to the body. But if you look at let me just finish this point. If you look at why is it possible that there was selection for heterozygous familial hypercholesterolemia in the previous centuries? Because it seems like there's some indication that there might have been. And if you look at that, there does seem to be a case that you can make that high levels of these lipoproteins protect against infectious diseases. And when the leading causes of death were infectious diseases, there was some selection for higher levels of those lipoproteins and would be consistent with cardiovascular health because cardiovascular health wasn't a major killer. And so now that selection has been selected for, we're now in a century where infectious diseases are not a major killer, cardiovascular is. And so now we see that antagonistic pleiotropy play out. But the fact that we can find certain things like red meat or coconut oil or egg yolks in some people but not others, saturated fat versus polyunsaturated fat, we can brainstorm a lot of different dietary constraints or dietary factors that would raise the cholesterol levels in people who have had that selection work against them in the current century. But that selection, the trait being selected for was high levels regardless of what elevates them. And well, for a specific reason that has nothing to do with those foods. So I don't see how.
Yeah, okay. It's a nutrient specific adaptation that is activated by that ancestral food.
No,
right?
but it's not. So, it's the genetic polymorphisms that underlie heterozygous familial hypercholesterolemia are down regulations of the LDL receptor. That's, you might be able to, and even the effective foods isn't even acting on that genetic locus in most cases. I would say that, it's complicated because there are, cascades of things. And so saturated fat does have some downstream effect on LDL receptor activity, but it's just a flat out hypofunction of LDL receptor activity that's causing that. So it's not like
I mean, it sounds like you're granting my point.
I'm granting your point that there are ubiquitous examples of antagonistic pleiotropy. I'm trying to dispute your point that these are nutrient specific because those nutrients existed in the conditions, like if it's true that infectious disease,
well, no, we just have adaptations to them. We just have adaptations to them. We encountered
the LDL receptor is not an adaptation to a food; it's an adaptation to infectious disease prevalence. If that hypothesis is true.
Well, okay. So here's the inference. Here it is again. If we have more adaptations to an ancestral food than we do to a novel food, then antagonistic pleiotropy is going to be more of a concern for that ancestral food than the novel food.
It's not an adaptation to a food.
What are you talking about?
It's an adaptation to a high prevalence of infectious disease that impacted a gene locus that is not directly a reaction to food. And, an example of
so wait. Just answer this yes or no. Does saturated fat interact with the concentration of LDL particles in the blood? Yes or no? Yes. Okay, so that's you granting my point.
I grant your point. No, I don't grant your point. So
no. Wait. So what you're saying is that saturated fat does not have interaction with the concentration of LDL particles in the blood.
I unambiguously said it does. I answered that in one word. I said yes.
Okay, so yes, that is you granting my point.
No, it isn't. Let me give you what my criteria for a nutrient specific selection example would be. To me, if you are positing that a selection is acting on a nutrient specific characteristic, that would be a that would be an example of that. Like a direct effect would be something that's impacting a gene that's directly controlling response to diet. I mean, that could be nutrient transporters or something like
that. I will also point out that I don't actually need to provide a concrete real world example of this in order for the inference to go through. I'm just entertaining this because you asked for it. It's not even necessary to show this.
I asked for it. Okay. Well, my position then, if you don't want to flesh it out further, my position is that if that antagonistic pleiotropy is acting on genes, and that the genes that are acted on, you can't target everything in the environment and say that they are part of that dynamic. So if the trade-off is between if the trade-off is, like, take another example would be cancer, right? So I think there's no particular reason why genes involved in cell growth and things like that would be beneficial in younger people would be selected for in to promote longevity if we don't have that type of longevity, and if that's not an important factor in evolution. But that doesn't mean that all like the sum total of things in the ancestral diet are more likely to cause cancer than anything that's not in the ancestral diet. That because not all those environmental factors have interaction effects with those genes. To take this specific example, if
like just to stop you, I'm not sure how this is interacting with my inference.
Your inference was that because there are because there are ubiquitous examples of antagonistic pleiotropy where genes have, so the principle, and tell me if you disagree with this. So the principle of antagonistic pleiotropy is that a gene can be pleiotropic, meaning a gene can do more than one thing and influence an organism's fitness in different ways, some positive, some negative. And because that, you can have an environment that selects for that gene to get the beneficial effect, and then also be selecting for the negative effect. And if you have a beneficial effect in a younger person and negative effect when the person becomes older, then you're selecting for a trait that reduces longevity in that. Would you agree with that?
Well, the way I characterize antagonistic pleiotropy is a little bit more broad, because I'm not just limiting it to single genes. I'm broadening it to whole adaptations, because I can't see a persuasive reason why we should limit it to just genes. So this could be morphological things. It could be behavioral things. The inference is just that it happens more often than it doesn't happen. And we just infer from that a priori that interactions with foods that are selected, or interactions, so adaptations to foods would also be likely to have this characteristic, because I can't see, like, what's the symmetry breaker between.
I know, I completely agree with that, right? Where I disagree,
okay, cool.
I completely agree with what you just said. Where I disagree with is I believe that you are conflating adaptations to certain traits because of certain parts of the environment with nutrient specific adaptations. Just because there is a nutrient that interacts with a pathway does not mean that the selection on every part of that pathway was a selection that had a nutrient interaction.
Well, no, that's just beside the point, right? So, like, okay, so yes or no? No, it is beside the point. No, I'm not. Like I said, it's not even important that I show a real world example of this, so I don't know where the conflation is coming in. So, yes or no? Compared to a novel food, we are likely to have more adaptations to an ancestral food.
You know what? I find that very difficult to answer, because it's very unlikely you're going to have a novel food that isn't full of ancestral ingredients.
Well, okay. So, like I said earlier, a certain amount of genes have to be defended in order for something to qualify as food, right? Like, like I've had people come up to me when I try to run this inference, and they say things like, "Oh, well, according to your inference, like rocks would be a great food, right?" And it's just like, well, no, because it doesn't even meet the basic qualifications of a food.
Look what I mean. Like, your example before was on red meat, right? Like, it's not red meat that does anything. It's when you eat red meat, you break it down to its components in your digestive system. By the time it's interacting with your blood lipids, it's specific components. So are you going to have an artificial diet that has no saturated fats, or has no iron, or has no hemoglobin,
maybe,
or whatever?
Well, not no iron, because like, not necessarily no iron, but like no saturated fat, perhaps. So, but the thing is that, like I said, it's not even important. It's not even.
Iron is an excellent example here, because there's a hypothesis on the development of hemochromatosis alleles that posits an antagonistic pleiotropic type of event, where under low iron conditions there was a benefit to increase iron absorption, that under high iron conditions it has. And I guess I think it would be an example of antagonistic pleiotropy, because even under those conditions, you probably have a negative longevity effect when you prevent anemia in young age, where when you get to old age, even in low iron conditions, those genes are probably negative. But that's a great example of something that acts on a nutrient. But note that it doesn't act on cereal grains or act on red meat. It acts on iron, which is a component of those things, which you have to have in an artificial diet. So I don't know how to think about whether an artificial diet could lack the constituents that we have adaptations for when we actually have to have many of those things that the adaptations are for. I don't know.
Because we have adaptations to compounds in food and things in food that aren't even nutrients. Like for example, we produce new 5GC antibodies, and that is an adaptation that we have to red meat, right? And that has nothing to do with nutrition, but that's an additional adaptation that we have to that particular food. So again, I'm just going to ask the question again. Compared to a novel food, do we have more adaptations to an ancestral food? Like compared to a novel food, do we have more adaptations to an ancestral food? Yes or no?
I have no clue, because we don't have adaptations to foods. We have adaptations to their constituents, and we haven't defined what the novel food is going to have for constituents.
Okay, so like I said just a moment ago, the food is more than just nutrients. Right, so like if you're talking about constituents, some amount.
How you define a nutrient, but yeah, I mean, I generally food is composed of things that are good and things that are bad, and you try to filter through them and absorb what's good and throw out what's bad.
So here's the thing, with essential nutrients, like I was trying to say, there is a certain number of gene interactions that are going to be defended in order for something to qualify as a food. It has to have metabolizable energy. It has to contain, micronutrients. All of these things have to be defended. So I'm just granting those, right? But in addition to those, ancestral foods are going to entail additional adaptations, correct?
Possibly. It depends how you it depends how you design the artificial food.
Well, no. Okay.
Yes, the probability is higher if you're just
okay. Cool. That's it. That's all I need. All I need. The probability is higher.
Hold on. The probability is higher, but the spectrum of probabilities are overlapping, because it's all dependent on how you design the artificial food. Yeah, I mean, yes, you could design an artificial food that is much lower in nutrient-specific adaptations, because it's just on the balance much higher in novel components for which we have no adaptations versus ancestral components.
Exactly.
However,
exactly.
However, if you're introducing novel xenobiotics, things that are foreign to the experience of the human, you have all sorts of unknown interactions, right? Because if you introduce one novel substance, the likelihood that this has no interaction with any ancestral genetics is almost impossible, because even though we might not have an adaptation to that specific thing, we have an adaptation to a class of those things. And a great example would just be like the entire class of xenobiotics, right? There's all sorts of adaptations to intestinal and hepatic xenobiotic metabolism that are class specific. They're not.
So
based,
okay,
and actually,
this is actually getting way off topic.
No, I'm
sorry.
Off topic at all. It's not getting off.
It really is getting off topic. Like, trust me, this is getting off topic. This isn't interacting with anything that I've said.
I don't trust you. I don't trust you on that. I disagree. But you can feel free to clarify why it's off topic.
Okay, so like a novel food, right? If it's genuinely a novel food, it meets all the criteria to be a food. Like, we can call it a food, but it is novel. We did not evolve consuming it. It by necessity has fewer adaptations associated with it.
No, I think that's complete bullshit, because let me give you an example. So, novel xenobiotics are universally metabolized by ancestrally evolved xenobiotic metabolism. I mean, a great example would be that, like, polyphenols are very similar to benzene, and they're actually better than benzene at
but this is just giving me a single example of a novel food that might interact with more than just an ancestral food. But you already granted me that on balance, it is more like.
No, it's true in general that that novel compounds are going to interact with pathways that were evolved to handle ancestral compounds. Good luck making something that's fat soluble, that's novel, that's not carried in lipoproteins. Good luck making a xenobiotic that needs to be cleared by the body that's novel, that's not interacting with it. I mean, why
when did I say like
exists in toxicology?
When did I say that a novel food needed to contain something like a xenobiotic?
A xenobiotic is
when did I say that?
Foreign to living systems, so it's almost by definition.
A novel food doesn't have to have new things that are. It doesn't necessarily have to have new things that are foreign.
Is it going to be absorbed? Are you going to get nutrients?
It could just interact. It could just interact with fewer pathways and not actually have any compounds that would necessitate the introduction of new adaptations or anything like that. It doesn't have to have anything new. It could, but that's not my point.
If you design it for the nutrients to be well absorbed, then in proportion to whether they are, it's interacting with all the pathways that were evolved for nutrient absorption.
Okay, let me rephrase the question. On average, are we going to have more adaptations to an ancestral food than a novel food?
I don't think we have adaptations to foods. I think we have adaptations to constituents within them, and
we definitely have adaptations to. Okay, so we have adaptations to their constituents. The food is the vehicle for those constituents. This is basically an equivocation.
Well, so I think you would have a higher probability of not having constituents that there were specific adaptations to, but you're probably going to have lots of, you're probably just going to replace those with constituents that we wouldn't say we evolved for that constituent because it didn't exist, but it's still interacting with things that we have adaptations for. I mean,
okay. So let me give you
look. Put this simply: like everything in a food has to either be absorbed or be rejected. And absorbing it is an active process that has lots of evolution behind it. Rejecting it and putting out into the feces is an active process. In many cases that's occurring in ATP-dependent transporter, multi-drug transporters, for example, that are rejecting thousands of different things as a class, right? So everything in that food is either absorbed or it's rejected. The rejection might be active, it might be relatively passive, but that act of absorbing it or rejecting it has to interact with evolved pathways, because all of the pathways that absorb
I accounted for this
are evolved.
I've already accounted for this. I don't deny this. It's like I don't deny this. Like a certain amount of genes have to interact, and that has to be defended. I agree. Now, again, on average, are we going to have more adaptations to an ancestral food than a novel food?
I think on average, you're going to have many more adaptations to constituents of the food that evolved as specific adaptations to that constituent when you have an ancestral food, because it has more ancestral constituents. And in a novel food, you are presumably having more novel constituents that
not necessarily. Not necessarily. They could just have fewer. Or they could just have fewer of those constituents.
That's right. I agree.
Yeah. Okay. Okay. So I could rephrase it a different way. Like on average, would you consider to be the case that we have more adaptations to the constituents in ancestral foods than we have to the constituents of novel foods?
It depends how those novel foods are designed, but the probability would favor that.
Yeah. Okay. So on average, we would have more adaptations to the constituents within ancestral foods. I think that's actually a pretty sound inference to make, personally.
Yeah, but it's sort of, I don't find it very meaningful in terms of being able to predict health impacts. I mean,
it just means that those ancestral constituents in those foods are more likely to be interacting with antagonistically pleiotropic pathways.
No, I think you're completely. First of all, I think the thing on the novel food. I think we're kind of distracting from something we never agreed on, which is I think that you're kind of making this logical leap from something that is selection on genetics. Like the whole principle is selection on genetics, and you're kind of making this assumption that all these genetic adaptations that could be antagonistically pleiotropic are all implicating foods as being antagonistically pleiotropic.
Nope, not at all. Not at all. This happens more often than it doesn't happen, right? And you granted me this earlier. It happens more often than it doesn't happen. And there's no reason to think that it wouldn't hold true for food constituent adaptations, we'll call them, than any other adaptation. Like, what's the symmetry breaker? Why assume that it holds true for other?
I don't disagree with that,
okay, cool.
But
that's great.
I don't disagree with that. I just disagree. My point of disagreement is on saying that because most nutrient-specific adaptations have the potential to be antagonistically pleiotropic, or by probability are just based on inference from some selection some survey that's been made. I don't know that that's true, but I'm happy to accept it for the sake of discussion. Because of that, then that means that correct me if I'm wrong about your inference, but I think that you're saying that because that should be true, therefore the ancestral foods are more likely to have antagonistically pleiotropic effects than to not.
Yes, correct.
Yeah, that's a point that I disagree on.
Why?
Because, well, for a couple of reasons. So first of all, most
I mean, it just seems weird to me because of what you just granted me. Like I laid out a few inferences and you bit the bullet on a couple of them, but now it seems like you're saying that's the opposite, or you're disagreeing somehow. Look, so it's a point of confusion here.
I think you and me have different styles to approach this. I would rather look at specific examples because I think it's easier to illustrate how the inference can go wrong with the example. So I'm going to use the example of hemochromatosis alleles being selected for by iron-poor diets that were high in cereal grains, which protects against anemia during the young portion of the lifespan, which is unambiguously beneficial because anemia is so destructive, but has a longevity negative because accumulated iron overload hurts longevity. And then that becomes even more harmful when you transpose those genes back into a diet where it's higher in absorbable iron. And so the inference then would be, if you look at what are the foods that's interacting with, well, it's not really interacting with a food. It's interacting with iron, which you have to have in your artificial diet if you're not going to make people anemic. And so it's sort of, it's clearly interacting with foods, but it doesn't have any implications for how to design a novel food that lacks the interacting factor. You can't, because the interacting factor is iron. But even still, if you say this is about the trade-off of cereal grains and red meat in the diet, you're not really coming to any conclusions about whether cereal grains or red meat are helpful or harmful. In fact, it's really more that the relative balance between cereal grains and red meat, perhaps the ancestral diet that was lower in red meat and higher in cereal grains is better over a certain portion of lifespan for a person who has those genetics that were selected for, because it will fine-tune the amount of iron they're absorbing to the genetics that were designed to lead to that amount of iron being absorbed. Whereas a different ancestral diet that is higher in red meat and lower in cereal grains might be bad for a person in that portion of the lifespan. Really, all this is the only thing this is leading to is to the selection of two different ancestral diets that might be more or less optimal for different types of people at different times, which falls back to what I suggested at the beginning, that my position is that the optimal diet for most people at most times in their life is going to fall within the spectrum of ancestral diets. And it really gives you no direction whatsoever on how to design an artificial food that will eliminate the trade-off, because you have to have the iron in the artificial food no matter what. And so I think if we took up any other example, I mean, go back to your example about blood lipids. So familial hypercholesterolemia, the example that you gave of this, I think you even agreed with me that when I disputed that this was food specific, because the evolution of the selection for familial hypercholesterolemia in the 1800s was a result not of anything to do with foods, even though foods.
No. Well, that's a mistake. All I'm saying is that food constituent has interaction with those genes. That's literally as far as I need to go.
Yeah, but which has nothing to do with the antagonistic pleiotropic selection of the gene. It's not. You know,
that's tangential too. That's tangential too.
I disagree, and I think that if you take this example, and let me just finish this point, and then I'll turn the floor totally over to you. So if you take this example of familial hypercholesterolemia, this is an example of antagonistic pleiotropy. The selective force is high prevalence of infectious diseases that are somewhat protected against or mitigated by high levels of ApoB lipoproteins, which was the highest priority for longevity in the 1800s and some centuries prior, when infectious diseases were the main killer, and is now, even then, if someone survived the infectious diseases long enough to get cardiovascular disease, it would be negative for them. But that happens more often now. So now we see the antagonistic pleiotropy taking place, where because we have lowered infectious diseases and we have a higher cardiovascular disease, we now see that play out. The spectrum of ancestral diets includes foods that raise ApoB lipoproteins and foods that lower ApoB lipoproteins. It's very easy to compose a diet of ancestral foods that is low in saturated fat, low in cholesterol, and will lead to normalized blood lipids in the average person with familial hypercholesterolemia. And if you were to design a novel diet to a novel food to deal with that, I guess you could make it zero fat or zero cholesterol instead of just very low. But all you're really doing is mimicking something that could probably be quite easily accomplished with foods in the range of ancestral diets. And so I think that what would budge my mind here is if you could, generate a specific example where one of these examples that are clear examples that interact with a nutrient in antagonistic pleiotropy, where the proposed solution is actually something that's not in the spectrum of ancestral diets.
Okay. So, do I have the floor?
You have the floor.
Okay, cool. So, again, I actually don't need to demonstrate an example of this in order for the inference to go through, A. And B, you've already granted me enough through our conversation in order for the rest of my inferences to just go through. So nothing that you really said over like the last 5 minutes really has any bearing on any particular part of my inference. So you've granted me that antagonistic pleiotropy happens more often than it doesn't, and I have specific arguments for that. I think that's pretty well documented. That's pretty well understood. You've granted me that on average, we're going to have more adaptations to constituents within ancestral foods than novel foods. That's all I need for that inference to go through. So I don't see how from those that the next inference won't go through. If a given novel food has non-inferior health value to a given ancestral food in the reproductive window, then such a novel food is likely to be superior to such an ancestral food in the post-reproductive window. If you grant the first two inferences, I don't see how you get away from granting that inference as well. And yeah, so honestly, based on what you granted me, like I don't understand where the point of disagreement would be, to be perfectly honest.
All right. Well, I'll grant you the last word on that. I think we've spent, almost an hour talking about your, your primary position on antagonistic pleiotropy. I think the best thing to do would be, I'd like to outline some points that I would kind of illustrate for my position rather than engaging with yours, give you a chance to engage with it, and then take some listener questions. I think I've seen some hands raised that maybe we can do 15 minutes of other people to get their points in or questions. What do you think about that?
Yeah, that's fine. That's fine.
All right.
Although there is one additional thing, just because I think in order for it to be equal, I have like a little bit more time because I only spent like a couple minutes.
Well,
I did have.
What do you mean?
Oh,
what do you mean?
Never mind. I just had like one more inference to go through, but it's honestly just like not even important. Yeah. So you can go on with whatever.
Let me switch to illustrating my primary argument, and then if you feel like there's anything that didn't get said at the end, we can go for a round where each of us can give a closing statement or something like that. Does that sound good? All right.
Yeah, that's fine.
Okay. So as I was saying before, my overall position is that from ancestral restraints, I think these are much less powerful than the accumulated basis of ancestral knowledge and wisdom that at generating ideas that are likely to be true. I think that it's better than random because there is a track record of consistency with human health, and so I think that generates some value. But I think that a much stronger heuristic is specific pieces of knowledge about foods that were accumulated through trial and error that we have not had the time to test. There's a lot of great examples of this. I think just if you look at early nutritional anthropology before we developed nutritional science, basically that extended to micronutrients, there's all kinds of little bits of wisdom where, if someone was suffering from vitamin A deficiency blindness, there was tribal knowledge to eat liver and eyeballs. And, you can say, well, it's just prejudice that the eyes are good for the eyes, but it is in fact true that you're going to cure vitamin A blindness with those. Or, just many pieces of knowledge, for example, in the Arctic where plant foods are very limited, they knew how to prevent scurvy by eating adrenal glands, which are the part of the animal that is richest in vitamin C. I think these are basically an accumulated. It's sort of like we have an accumulated body of knowledge, and doubtlessly much of it is wrong. But because we had reasons to get there, and because it's helped us survive, you're better off tapping into that body of knowledge than you are to a random idea generator. And so not everything is going to be true, but it's just because of the trial and error that's gone through, you have a basis of knowledge in response to fixing many errors on the path of experience. That is just a much better source of information than a random idea generator. But I guess I want to go back to what I had said about, because you seem to be specifically interested in whether we can develop novel foods that are not ancestral, that are superior to ancestral foods. And so my position on that is that in theory, we should be able to do that, but I would have extremely dim prospects for being able to do it in any kind of time frame, on any kind of time horizon where we wouldn't cause a lot more harm than good first. And my primary way, I obviously neither you nor I can see the future. And so looking over the next 50 years of developing lab grown meat or whatever, or the next meal replacement drink or whatever it is, neither of us have a crystal ball where we can know what's going to happen. And so the way that I like to look at that is to look at what happened the last time we did that, or the last 2 or 3 times that we did that. And if you look at what they did with purified lab rats. So let me give 3 examples. One is purified rodent diets. Second is total parenteral nutrition, which is intravenous nutrition, and the third is infant formula. So I'll try to go on them quickly, and then I'll be able to answer questions if you have any for me. But But very briefly, in lab rats, what basically happened in the 1970s is scientists wanted to standardize lab rat diets so they could more easily compare toxicological studies and know that the diets were not variations between them accounting for different results. And so when they did that, they took everything that was known in the 1970s about the nutritional requirements of rats and fed them a diet that they made based on the best science of the time, rather than the random food that it just happens to be in the spectrum of natural foods. And so what happened first was the rats developed kidney stones, fatty liver, and had widespread internal bleeding of the brain, intestines, and other organs. So they looked at this and they said, why? And they increased the vitamin K 10 times to prevent the hemorrhaging, and they put in starch and took out sugar to protect against the fatty liver. And then they still kept finding that these rats were vulnerable to stress toxins and carcinogens that natural chow diets were not vulnerable to. And so they started looking at, why is this? And what they found, they looked at fiber, essential fatty acids, antioxidants, and they couldn't find anything. They played around with the protein and they found some things. But the main hypothesis was that the polyphenol constituents of plant foods in the diet were necessary to rev up the hepatic detoxification system. And when they went through and looked for a specific component, it actually looked like you get a synergistic effect of multiple components, and we don't really understand that synergy. But generally speaking, you can give specific examples. Like one study of green tea catechins showed that even though everyone wanted to boil down green tea to EGCG, it turns out that EGCG is much better at preventing lung cancer when you give it with the other catechins that come with green tea. For whatever reason, we don't really know why. So anyway, in the 1990s, after studying the negative effects of the diets for 15 years, they reformulated them again. They increased choline, they increased essential fatty acids, they increased vitamin K even further. They increased the calcium to protect against kidney stones, vitamin E to protect the soybean oil from oxidation, et cetera, et cetera. They upped the vitamin B12 because they actually had lab rat data on methylmalonic acid responses to different B12 doses in rats at that point. And at the end, these newer diets were better than the ones made in the 1970s, but there's still evidence that they underperform standard cow diets for protection against toxins and stuff like that. And in fact, they even added a mix of ultra trace minerals that include even toxic ones like arsenic. And the reason that they gave was that basically we've messed up so much in assuming that we knew the nutritional requirements of lab rats that even though we have no specific evidence that some of these ultra trace minerals have any effect at all, we should put them in there because they occur in food and they might have an effect that we don't understand. And so they even just at the end of that, they just basically gave up and said, these are purified diets. We're just going to throw stuff from food in there because we don't understand all the things that it does, but we still can't make a purified diet that is superior or even equal to what was to the chow diets that were really just like random cereal grains and fish protein and stuff like that. Something very similar happened when they made total parenteral nutrition for humans. So total parenteral nutrition is 100% intravenous nutrition. And when they first started developing it, they had safety studies in puppies that suggest that including fat in the TPN increased the risk of developing fatty liver. And so as a result of that, they actually made it fat-free at first. And when they made it fat-free, people started getting eczema on it. And so Ralph Holman, who was a student of George Burr, said, we believe this is from deficient essential fatty acids. And so they made two different variations. One had safflower oil and one had soybean oil. And the safflower oil had an omega-6 to 3 ratio of 115 instead of the much more mild one in soybean oil. And in 1978, there was a 6-year-old girl who was shot in the stomach, and she was on this soybean oil TPN for 6 months. And she started developing severe neurological problems, double vision, peripheral neuropathy, et cetera, et cetera. And so then in the 1990s, basically, they figured out how to formulate the omega-3 omega-6 balance. But then at that point, they found that people in general, so in the 1990s through 2001, they generally found that liver disease which was like a leading cause of death in people with TPN, was probably a result of not putting choline in it. And so it was actually in the late 90s and to 2001 where we declared choline an essential nutrient in humans, which was not previously recognized. And it was recognized because when we thought you could make all the choline you needed based on modern science, when in fact we tried to make a purified diet based on current scientific knowledge, we gave people liver disease over it. And so, and then there are other examples with taurine and other things like that. And if you go to infant formula, you have a very similar history. I'll go through it in a more brief way. But the gist of it is that the early idea was that you should make formula look as much like human breast milk as possible. And when we decided to transition, and granted, this is much earlier than these other two examples, so nutritional knowledge was not at all very good around the turn of the 20th century. But around that time, when they changed their view, and in fact, if you look at culturally what was happening, it was that people were changing their view to believe that science made things better. And so when culturally we developed the idea that the things that we can make with science are better than the things our ancestors were doing, that's when they started making formula based on powdered milk and high fructose corn syrup and hydrogenated coconut oil. And that's when we got, all kinds of problems from that. And there were actually many disastrous incidences where the FDA kept making more and more regulations about how to formulate infant formula, because basically right up through almost the modern era. So it takes us into the 1980s, for example, whether to decide whether to put taurine in infant milk. And if you look at that, they never really made a strong science-based case that you need to have taurine in infant milk, but they did show that that children who were on TPN did need to get taurine, or they had very concerning neurological problems from it. And so they basically went to taurine by default, where it's not necessarily agreed on that it's required. But we basically fell back on, let's start just throwing stuff in that might be helpful, because in fact, when we were just trying to model breast milk, we were doing exceedingly better with the health of infants than at any time where we were trying to scientifically modify breast milk based on current scientific knowledge. And so, granted, scientific knowledge at the beginning of infant formula was very poor, but the lab rat diets is taking us through the 70s into the 90s, and choline and TPN is taking us right into 2001. And yeah, we know a lot more now, but I think that our knowledge of essential vitamins and minerals is very good. Our knowledge of polyphenols and other constituents is extremely poor. And if you go back and look at what was one of the problems with their lab rat diets, where even into the 1990s, they could not make lab rat diets that could match the health benefits of standard chow diets completely. One of the things that they were looking at was the polyphenolic constituents of the food that we still don't understand their effects. There's thousands of them. There's obviously negative effects and positive effects of them. There are obviously synergies and antagonisms and additive effects. And with thousands across foods, and there's also class effects of polyphenols in stimulating hepatic and intestinal detoxification. But then there are also very individual specific effects of polyphenols, where they might act on certain opioid receptors in one case, where they might act on any given other pharmacological target in another case. And my personal suspicion, I can't tell you logically this has to be the case, but my personal suspicion is that if we go on to produce artificial foods, we're not going to make all the same mistakes that were made in these three examples over the last century, because we've learned from them. But we're going to make analogous mistakes where we think we know the good things and the bad things, and only by trying to fully optimize in a way that we cannot optimize with natural foods? Or are we going to realize new problems that we're creating that we will have to fix down the line? And I do wonder if maybe this takes 50 or 100 years to play out, but then we wind up in the same case that we wound up with purified lab rat diets or infant formula, where we throw up our hands and say, you know what, these constituents, we still don't completely understand them, but they're found in natural foods. So let's just throw them in. And maybe that's why, maybe these being missing has something to do with why these purified artificial foods are not producing equal health outcomes to natural foods. And so that's what I would see going forward, just based on the history of any example that I can generate in the past where we've tried to do that. And that's not a logical proof. It's just an expectation of how to model the future based on how we've experienced the past.
All right. So
I'm up. Yeah, you have.
Oh no, sorry. Okay. Yeah. So my closing statement won't take very long. Like, my position is basically.
Should we do closing statements and then do 15 minutes of questions, or how is that the best thing?
Yeah, that's fine.
Okay.
I'll include my response to what you just said in my closing statement.
Sure.
So yeah, my position is a principled epistemic position. It doesn't take on board any of the scientific or empirical challenges that we face when, trying to find novel foods that are superior to ancestral foods. Like, all of that stuff is actually tangential to the point. So like all of the things that you were describing were all good examples of empirical and scientific challenges that we face when trying to come up with these novel foods. That doesn't really have anything to do with my position, which is basically just a principled epistemic position about what is probably likely to be the case in principle. That's what my position was on. So just for clarity for the listeners, like, honestly, I don't even think Chris disagrees with this. He granted me enough to make my inferences go through. He granted me that in principle, we should be able to design novel foods that are superior to ancestral foods. All of the scientific and empirical challenges that we face in getting there is all completely irrelevant to my point. So yeah, that is basically my closing statement. And I guess we can turn over to questions.
Okay, so I'll make my closing statement, and anyone who wants to ask a question or make a comment, please raise your hand. I believe there's a request thing at the bottom where you can click it. We'll see your hand raised, and we can activate the mic on you, and we'll go to questions or comments if there are any for 10 or 15 minutes after my closing statement. So my overall position is that ancestral restraints are a moderately good source of hypotheses to test about insights that might have important health implications, where deviations from our ancestral environment are responsible for health problems. Those are hypotheses to test. They are not things to assume. And I believe that ancestral environmental restraints are a better than random source of hypotheses. And I'm not going to make any claim on whether they're better than any other non-random source of hypotheses. I think they're one good source of hypotheses, not necessarily that they're better than other good ones, just that they're better than randomly generated ideas. I am much more interested in what I believe is the higher health value of the accumulated body of ancestral health wisdom. I believe that because that wisdom was accumulated in response to it, much in the same way as modern science, they had different tools, but they still had the same process that you and me both agree on, where they too were making errors and fixing them and accumulating the knowledge gained from that experience, just like we do. But they were at it for much longer, many, maybe thousands of years for specific environments and millions of years in general. I don't know if I'd go that far, but especially given, where we started our ethnography. So what we know is probably hundreds to thousands of years of experience that was built on knowledge that went even farther back than that. And so I think that's very valuable and shouldn't be dismissed and should generally be used as a framework to interpret uncertainty. When we don't have something that modern science has settled, I think it's a good fallback to fall back on whatever the commonality among ancestral wisdoms is, because I think it's better than random. And I guess we do disagree on that. And I agree with you in principle. Well, I guess on your position. So I don't want to state from my own knowledge, because I've never done an analysis of the relative ubiquity of antagonistic pleiotropy in nutrient-specific genetic adaptations, but I'll accept for the sake of argument that it's above 50%. I think where we disagree is that I don't believe that because antagonistic pleiotropy is more common than not, that translates to ancestral foods are more likely to be harmful than helpful in probability wise. And I gave specific examples that I think did sort of empirically refute that, not in a quantitative sense, but in a qualitative sense. And I do agree with you that in principle, we should be able to make a novel food that is better than all ancestral foods. But every time we've tried to do that, we failed. And I gave you historical examples where this failure persisted over decades and caused actually disastrous consequences on the way there. And in no case was it ever not concluded to throw our hands up and throw in stuff. Well, actually, I think TPN is probably a good example where we didn't throw our hands up and just throw in everything that exists in foods. But that's largely because that's such a short-term intervention in most cases, and also because there's lots of things you can't just inject into someone. But it's the general trend with rat diets and with infant formula that we did wind up throwing up our hands and just throwing stuff in from foods because we could not produce something that was superior to what existed in nature. So that's my closing statement. And I don't think we have any hands raised. I don't see any. Do you see any hands raised, Nick? I think we had some before, but no.
Yeah.
Jumping right now. All right.
Wait. Just 1 second. I think Avi wants to jump in. He just had something to do.
Yeah, before.
Yeah. So
add a speaker. Hi, Avi.
It was an unfortunate debate that you two just had. Mainly because you didn't understand the position and it wasn't conveyed well. So it's partially, I think it's partially because we're just giving rambling responses and partially because it was explained to you in a very half-baked way. If you want, I can explain to you what the position is. And from the top down, I don't know how much time you're willing to give to other people. So that's up to you. It may take more than 15 minutes, but if you want to know what...
So look, what Nick and I agreed on beforehand, which I stated at the beginning, was we could give about 15 minutes or so for questions and comments at the end. And so I think that because no one else has their hand up, you can take the floor for 10 or 15 minutes. But, if you want a response, then try to go 7.
Okay. Well, I suspect it will take longer than 15 minutes. I can try. But okay.
Well, then either throw it out or break it down into something that you can do in 5, 6, 7 minutes.
Well, if I was gonna be, well, the reason I said I suspect it will take more than 15 minutes is because I suspect I won't be able to do it to break it down 5 minutes.
Yeah, but I get that, but we all agreed on
yeah, that's why. If there's no more hands up, here's what I'll do. I'll try my best. If there's no hands up at the 15-minute mark, would it be okay if we keep going?
You can keep going, and Nick is co-host. So I guess you can take over the floor, but I want to head out in about 15 minutes.
All right. Okay. So real quick. The idea of antagonistic pleiotropy, what it's taken to be is just that I mean, a very trivial oversimplification of it is just one gene having multiple different effects, but it's not just at having multiple different effects at different time points aren't just limited to genes themselves. They're the effects, and nor is it limited to monogenetic interactions or food-specific interactions or any of that. It's at the level of behaviors, which are influenced by many different genes. For example, when a black widow spider engages in mating and eats the male black widow spider, that is an antagonistic pleiotropic behavior. And that is influenced by the interaction between their genes and the environment, why that behavior is there. It's not a monogenetic thing. It's a very complicated polygenetic behavior that results from that interaction. And we don't know exactly how it happens, but it does happen. And it results in an antagonistic pleiotropic effect. Behaviors, and it is an adaptation. It's not a monogenic adaptation. But it's a behavioral adaptation that happens, and it increases reproductive fitness at the expense of health in old age. Very trivially, similar things can be found across the animal kingdom. Similar things happen in octopus. There's an example of octopuses. They have a certain nucleus in their not a cellular nucleus, but nucleus in their brain that turns off for feeding or hunting when they lay eggs, and that's to devote all of it. You can create certain environments.
I don't know if it was my internet or yours, but I didn't hear the last 10 seconds.
Oh, you might be having a connection. Yeah, so I was just talking about how similar things are in octopuses. It's behaviors that are antagonistically pleiotropic exist throughout the animal kingdom, and they exist at levels of behavior. And food.
Well, I just want to interject very quickly. I mean, this is basically a subset of trade-offs that are ubiquitous outside of evolution.
Sure. Yeah. No, that's not being disputed. But
the principle of an opportunity cost or a trade-off is going to be ubiquitous. Yes. In some cases, it's genetically adapted.
Yeah. Right. But But the point is just that there's a tendency for evolution to select for a certain type of trade-off rather than a different type. So the type of trade-off that evolution is likely to select for, behavior or otherwise, are the type of things that will improve survivability during the reproductive years at the expense of survivability to old age, in the old age years, post-fertile years, rather than the reverse. It's not going to be as likely to select for behaviors that are going to decrease survivability during the fertile years, but have the benefit of.
Avi, can I step in for 1 second just to throw a point that you can engage with? So I agree with that,
mm-hmm.
but I think it's important to point out that if selection is acting on human behaviors or animal behaviors about which foods to select, it's not actually dictating the foods available in the environment.
Sure, that's fine. That's great. That's not needed for.
Okay. Well, the reason that I think this is relevant is because, the way that you're describing this, what I would imagine in my mind is that humans have sets of food-seeking behaviors that are going to have negative effects on longevity.
That's not. I mean, okay. No, it's not quite. That's not what I'm saying. What I'm saying is that humans are more likely.
How would you phrase
that? Humans are more likely to have food-seeking behaviors that are going to have an increased in pre-reproductive longevity at the expense of post-reproductive longevity, rather than food-seeking behaviors that have pre-reproductive longevity decreases and post-reproductive longevity increases. So there's four parts.
I agree that the way you just stated it was stated much better than the way I stated it. But that's
trivially true.
Agree on this point.
Wait, what?
I agree with what you just said.
Okay, yeah. So that is the first thing.
Well, let me just throw out why I brought that up. So the reason I think this is relevant is because it's one thing to say that the food-seeking behaviors within the ancestral food availability spectrum are selected for in that way, and it's quite another thing to say that the sum total of constituents available among ancestral foods are more likely to promote pre-reproductive longevity than post-reproductive longevity. What's being acted on is the behavioral trait, not the environment. Right? There's other evolution that impacts the environment,
of course. But yeah. So what's being said is that there are certain behaviors that our ancestors have engaged in with respect to food seeking. There's a whole bunch of them. I don't have the time to enumerate all of them, but we agree that there are certain behaviors that have been selected for. And what's being said is that there's like if we divide it up by a 4x4 grid, we for the sake of simplicity, we avoid neutral selective effects. And we just say, okay, well, let's just arbitrarily take 40 or 45 as the reproductive age and say, well, we have pre-45, post-45. We'll just call it pre-fertile, post-fertile. One behavior could be advantageous for both pre-fertile and post-fertile. Another behavior could be disadvantageous for pre-fertile and post-fertile. Another behavior could be advantageous for pre-fertile but disadvantageous for post-fertile. And another behavior could be disadvantageous for pre-fertile and advantageous for post-fertile. And all that's being said.
And so it's worth pointing out that the sum total of all behaviors that are beneficial to pre-reproductive fertility include many that are also beneficial to post-reproductive fertility.
Sure, yeah, of course, yeah.
And what's explicitly selected out is the other two.
Well, yeah. Well, generally speaking, yeah. So what's going to be selected out is going to be of the four things, the things that are going to be selected out are going to be decrease, and decrease. The things that are going to be selected for are going to be increase, and increase.
Right. And so if let's say that 51-49 we have the antagonistic pleiotropy, then what then is the distribution of behaviors that are beneficial post-fertile? It's pretty significant.
I'm sorry, I'm not understanding what you just asked. All I'm saying is the only claim I'm making right now is that increase decrease is going to be selected for over decrease increase.
Right, but if we
I'm granting there could be increase. I'm granting. Yeah.
Right, and so all I'm saying is that if there's 51% are increase,
mm-hmm.
Are increase decrease, and 49% are that are selected for, not of total behavior. If 51% of selected for traits are increase decrease, and 49 are increase.
Yeah.
Then like 49% of selection is for post fertility.
Sure. Yeah, that's fine. Yeah. But divorce. Okay, Chris, just divorce everything you've heard from Nick in your previous discussion. Okay, like don't bring anything from your previous discussion into this one, please.
Well, the point of this one is to shed light on the previous one, but
no. Okay. Well, yes. But the problem is that one was done so poorly that I think it would be more productive for you to try to just divorce any preconception of where I'm going with it on the basis of your previous discussion.
Well, I might wind up agreeing with you more than I agreed with Nick.
Yes, and I think you would do that if you just don't. I'm just saying, don't try to anticipate where I'm going with it.
Right? Okay. Okay, well, I will not anticipate where you're going, but I will ultimately want to bring it back to the discussion that we just spent an hour and 15 minutes on.
Well, you might or might not, because it might be a different. It might be a different.
Right. Let me reflect at the end, and
Sure.
I'll refrain from doing that now.
Okay. Cool. Now, the position that I'm advocating is that if we were to find a, however we define ancestral diets, there's a number of ways of doing that, but however we do that such that it maps onto what we're talking about here, and however we define artificial diets such that it maps onto the things that are not going to be amenable to those types of selections in either way. So what I'm saying is that if we were to find a quote unquote artificial diet, that not any artificial diet, but the subset of artificial diets, and it could be one that you could argue doesn't even exist yet. It could be one that you could argue would only exist deep into the future. That can be disputed, but you can make it. But whether that's a diet that exists now, whether it will exist in the near future, whether it will exist in the far future, that's not the point of the contention of what I'm saying right now. All I'm saying is that of the artificial diet, there is a subset for which the health promoting effects or thriving or longevity effects of the fertile years will be on par with the ancestral diet. There's going to be some subset of artificial.
So let me just say that I agree with that in principle. The problem is that, from my perspective, the problem is whether it would be reasonable to believe we could achieve that, because achieving it would first require our knowledge to be refined to such an extent that we would know how to.
Okay, so I hear that. Yep. I hear that. That's not the purpose of the.
And let me also just point out that I must believe this because my own diet is a hybrid of ancestral diet with some supplements that weren't available ancestrally.
Sure.
Right.
And again, that's not part of like that. I could grant all that, and everything I'm saying goes through. So like that's not you
were saying. I'm just clarifying.
Yeah. Sure. And I've heard that. I understand the position. So what I'm saying is, if we find this subset of artificial diets that is just as good in the fertile years as the ancestral diets, then the question I'm asking, and I'm going to answer it, is that, well, which one is likely to which one is going to be more likely to be healthful in the later years of life? And my answer to that is it's more. Sorry.
Finish that, and then I want to jump in quickly.
Yeah, my answer to that is that for that specific diet, that's just as good or better for the fertile years of life. It's going to be more likely to be better for the later years of life than the ancestral diet. And the reason for that is because we've already selected for the artificial diet that already has all of the fertile benefits, but once you make that equalization, then the artificial diet has the added benefit of not having antagonistic pleiotropy behaviors being selected for, or at least the food-seeking behavior associated with.
So I agree with this, and I find it obvious.
Mm-hmm.
But this reminds me of a famous joke that was told on the first day of my Economics 101 class in college, which is, and I forget the exact joke, but it's 3 specialties wind up on. An economist and 2 other people wind up on an island, and I forget they have to open a can because it's the only thing they can eat. And I forget what the other 2 were, but they each put forth their suggestion, and then the economist says, "Assume a can opener." And so the joke is that economists make all sorts of premises that don't necessarily play out empirically. and you can't assume a can opener because you don't have one. So I mean, in that context, the reason that reminds me of the joke is that you're assuming the perfection of the knowledge required to produce that diet. And yeah, I mean, if you assume the knowledge of that would be required to produce that diet, then of course the probability of that diet fulfilling your goals when you have perfect knowledge is, I mean, if your knowledge is perfect, it's 100%.
Well, sorry, just to be, it's not perfect knowledge. It's just knowledge enough to know that the pre-fertile.
Right, but no, we agree. Yeah. But I mean, what that means is that you have this presumably asymptotic increase in knowledge that approaches perfect knowledge.
Well, I don't think that follows.
Well, I mean, if you postulate the possible future increase in knowledge, you could say it looks something like that.
Well,
or it could look something like that.
Sure, I agree that might look something like that. But all I'm saying is that in order for one to have a diet that, so first of all I've said so far, like we can talk about what it would entail to get a diet like that. But all I've said so far is, and I haven't assumed anything. I've just said if it was a conditional. I've said if we were able to have a artificial diet, which was a subset of artificial diets that was just as good as the pre as the ancestral, then we have reason to believe that said artificial diet would be better than the post than the ancestral. That's all I've said so far.
Right. I mean, you could take out the word assume and just say if we had a can opener. Because
that's not. That's a conditional.
I agree with the principle, but my point is, and I'm not imposing anything Nick said on you. I'm just clarifying my position. My objection here is not that what you said is wrong. It's that the historical experience of ever having tried to do anything like this has suggested that no matter where we are, we probably don't have that knowledge.
Okay, so that's a very different.
In the absence, wait. Let me just finish the sentence. If in the absence of sufficient knowledge, we are to produce a range of artificial diets that we think will work for that purpose, I don't think you actually have a favorable probability. But whereas I think if your knowledge is better than it isn't, at some point you get to the point where, because your knowledge has advanced that much, then the artificial diet that you produce does have a favorable probability. I just don't think we're at a place where if you tried to make one now, you'd have a favorable probability.
So all of that could be granted.
Part of my priors are every historical example I can find where someone tried to do that.
Okay, so all of that can be granted, and that's not an objection to anything I said, because everything can be granted, and what I said is true. So, like, when you say you have an objection, just be careful about that. So, okay, so I could agree with all of that. Incidentally, I don't know if I agree with that. In fact, I suspect that your position there is exaggerated, and that the degree of how close one is to get to a diet that's being comparable to an ancestral diet may not be as far off, if not here already, than you may think. But maybe I'm wrong about that. But regardless, from what I've said so far, I could take your position that it's far away, and I could even grant your position that we've, every time we've tried, we failed. I don't actually really agree. I don't, depending on how we define what the diets are, I'm not sure if I even agree with that. But I could agree with all of that, and it's not an objection to anything I said. So the point I'm just making is that,
right, I don't object.
Okay, cool. Now, there could be a discussion. There could be an open discussion of how far away we are from having an artificial diet that is comparable to an ancestral diet in the fertile years. That's an open discussion. You could say, okay, well, do we think it's this far off away? Do we think it's already here? Do we think it's like 10 years, 20 years, 50 years, 100 years? Like, we can, it doesn't require perfect knowledge to get there. Like, you can have imperfect knowledge and still stumble upon, have a knowledge enough to stumble upon a diet that meets that. All I'm saying is, once you do that, once that's done, you could make an inference that if you have the information that it's good enough from ages 1 to 45, it's probably, well, not good enough, but comparable to the ancestral from 1 to 45. It's more likely than not to be better than the ancestral from 45 to 80. That's all that's being said.
Yeah, as a theoretical construct, I don't disagree with that at all.
Yeah, cool. Okay, awesome. All right, that's it.
Well, okay, cool. I mean, so just like to go back, just to reflect on the question at hand, whether, I guess, is ancestral health a useful or terrible heuristic turned into what exactly is the value of ancestral health as a heuristic? And I guess we kind of, I don't know that we answered this in any kind of binary way, but I think, even with Avi, what you just said, I think what's your answer to that question? Do you think the ancestral heuristic has value?
It depends what we mean. I mean, compared to, I think it's a relational.
Well, so we do have another hand up. So what's your sort of like 30?
Yeah, sure. Yeah. So my 30-second answer is, it depends. Yeah. So my answer is yes, relative to other things, certain other things that are worse, trivially, like relative to a standard American diet. Yeah, people probably have better health outcomes on quote unquote ancestral diets. Do I think it's the best heuristic relative to other people's goals? That depends on what their goals are, and that's depending on how we're cashed out ancestral diets. I suspect that there are going to be some ancestral plus artificial modifications, or these, whether you call that an artificial diet or a hybrid diet, I don't really care. But it's not going to be just a purely ancestral diet. If you're trying to answering what diet is better for the goals that I think most people have, it's not going to be some purely ancestral one. I think it'll be some other heuristic, which is ancestral plus some artificial modifications.
All right, cool. Thank you, Avi. So let's now go to Sar. Sorry, you're muted. Hey, Sar.
Hey.
How you doing?
Good. So what I wanted to add, I think that even the conditional that Avi raised, I think that even that is incorrect, because it's not like the post-fertile years are like complete junk. These are years where knowledge is transferred, where people help offsprings. So you can't just say that if you have a diet that's equal in value on the fertile years, then it won't have the antagonistic pleiotrope in the post-fertile years, then it will be definitely better, because there is also selection for post-fertile years. So I don't see how that would work.
Avi wants to, I guess, respond to that. Avi,
the dumbest objections to this I've ever heard, and it's it's amazing. Like, people like bring up this objection, like, while not taking the time to think of, well, what would he respond to such objection? Like, didn't he hear this before? Like, wow, okay. So yes, obviously, I'm not claiming.
I don't think you need to attack the audience.
Oh, well, I mean, in the case of Sar, I know him previously as a motivated reasoner in interactions with him, so I'm not attacking the audience.
We don't need to.
All right, so that's fine.
It's okay. I don't care.
So just to respond to what he said. Yes, nothing in this inference rests on there being zero selective effect in the post-fertile years. Obviously, no one's like, the reply if someone says, well, isn't there some effect of selection in the post-fertile years? Is it knowledge being transferred down? Isn't the wisdom of the answer? And the answer to that is, yeah, no fucking shit. Like, yes, but if you graph out the selective effect of it over time, what you see is it goes down. Yes, there is some minimal one, but it doesn't need to be any non-zero value in order for that trade-off to be made. The trade-off is just more.
I'm not sure that
I can send you literature on it if you'd like.
Well, I'm not sure if maybe I disagree with both of you on this, but I don't actually think that the body of ancestral wisdom is largely shaped by genetics that have been selected.
That's fine. I'm pointing out,
like obviously the capacity to develop the knowledge is shaped by evolution.
Yeah,
but I think it's just wrong that the body of human knowledge has any kind of genetic locus per idea
I don't.
that has any
That's fine. Again, the point
That's
is
all that I said.
Wait, hold on. Let me. I know that you're responding to Star, but I want to kind of riff on what Star brought up, because I did want to say this before and I didn't quite get to it. I do think that just as our body of knowledge that we are developing right now, or that we're relying on right now to discuss, just like that can correct something that is embedded in our behavioral traits that have been selected for perhaps 51-49 in favor of, decrease at the post-fertility range, perhaps. We have knowledge bases that counteract those behaviors, and like the concept of knowing something and acting on it with discipline is not a modern one. We didn't invent that just now. This is something that you find in ancestral wisdom. Like, one of the things that Weston Price noted in Nutrition and Physical Degeneration was very specifically that the groups that he studied had discipline and strength of character to go great lengths to procure specific foods that were not in their immediate environment. And that is, that doesn't necessarily mean that that's beneficial to post-fertility longevity, but it's an example of something where they clearly have beliefs and resolve to act against their more basic genetic behavioral traits, which might, obviously resolve is something that has some genetic locus, but so does laziness. And they have a belief system and a body of knowledge that encourages one genetically encoded trait over another in order to counteract whatever would just happen to them if they followed the easiest path of their genetically encoded behaviors.
The points in response is just really simple. It's just that nothing. The conditional doesn't in any way rest on an assumption that there's no selective pressure during the later years of life. It's just
we know that. We clarified that before.
Yeah. So why is the conditional false?
Sorry.
So the way you worded it originally, you said that you were going to be equal in the fertile years, and therefore, because you don't have antagonistic pleiotropy in the post-fertile years, then you are probabilistically advantageous. But if there is some value, there is some selection in post-fertile years, then you can say that, because it's possible that the nutrition has been selected the way the body tastes food and the way we are motivated to seek it. It could be also motivated to support these post-fertile.
Yeah, no, what I mean by post-fertile, post-fertile is whatever year. So by post-fertile, I just mean whatever the year. It doesn't have to be 45. It could be 50. Whatever the year is, such that the selection for antagonistic pleiotropy outweighs the beneficial selections in those post-fertile years.
But basically, you're just getting to etaology.
Yeah, no, yes, it would be crazy to deny. But the point is, there is some year. Like, okay, maybe it's not. Maybe I'm wrong about 45. Maybe it's 50. Okay, fine. Maybe at the age, maybe it's not 50.Maybe it's 55. But the age is 55.
There's no age. It's a gradual process. There's no age where it's.
No, there's an age where there will be a crossover. Okay. So obviously, I'm not claiming that there's an age where it stops. There's that's tangential. What's being claimed here is that there is an age where the antagonistic pleiotropic selections override the beneficial selections.
Obviously age is a proxy for other, in some cases binary, menopause is binary. And so average age of menopause is is a proxy for that in the case of fertility. But I think there are examples, not all antagonistic pleiotropies are about fertility. Like, in some case, they're about just the earlier causes of death versus later.
Yeah, that's fine. I grant that. I can grant that, and the conditional is just as true. I think Star was maybe. I think Star, maybe you're missing the point that Avi and I agreed on, which is that there are some. There's basically four combinations of increase, decrease, increase, increase, decrease, 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 increase, where the selection is for any of those that have an increase in pre-fertility longevity or early longevity component to them. And so I think we're all in agreement that there is some selection
post-fertility longevity that exists.
Yeah, and there's some point.
I mean, it's all a trade-off. It depends on how strong would be the benefits in later years in helping the person support the offspring. So it's not, you can't just make a 2x2 matrix here. You need to actually weigh each gene with its effects, and it may be smaller, bigger, in different years, and it could be gradual. And I think once you take into consideration all of these, just end up with a statement that if I have a food that is better in all over the lifespan of the person, then it's better. That's where you basically end up.
So this is again, so what I've tried to say, and what's not being recapitulated here is just that there, as age goes on, there's a tendency for the effect of antagonistic pleiotropy, which is a behavior that's going to be increase, decrease, for a given age would override an effect of increase. It's just as one for a specific age.
Yeah, but we don't do it. I mean,
wait, but this is what is the key to response to
quantitative data on that.
Wait, but this is critical, because the reason in evolutionary theory for this is just that as you get closer and closer to death, early adaptations that are going to be favorable for, to get the difference between 85 and 86 versus the difference between 50 and 51. Like it's going to get less and less important as you get older and older and older, because you're just closer to death anyway. And so the point is that there's just going to be some age that you can make that statement at. It's not going to be that there's no.
Well, I think part of the issue here is that death is a binary outcome, and so if something is death promoting, it doesn't have the magnitude of it becomes irrelevant. And so the simple fact that we're not immortal sort of shows sufficient proof that antagonism of longevity wins out in the end.
Well,
I don't think that's. I think that's easy to agree on. That's very basic, but that's not the issue I'm raising.
Well, the issue Sarah is raising. Right, Sarah is raising the issue that what he's saying is that, well, look, if it's the case that there is some selection in favor of survival in the fertile years, then you can't simply say that if there's there is an equal amount of something in the fertile years, then just because antagonistic pleiotropic effects aren't there in the later years, then it would be better, because it could just be that there's a countervailing selection effect for the post-fertile years. Now now he's correct on that. That's true. It's true that you can't just say that. Now there's a number of responses to that. The number of one response is that if you were to actually start doing an investigation in terms of which is more likely, in terms of which adaptations are more likely, increase, decrease versus increase, to the chagrin of those who you want to push the ancestral wisdom evolutionary narratives. I can make the case that actually increase, decrease is far more likely than increase. That's one response. The other response is just that even if it's not the case, even if increase, decrease is not far more likely than increase, even if they were roughly comparable, at some age they diverge, and they're going to diverge in a direction where increase, decrease will be overriding for increase. And so there will still be.
I agree with this. I agree with this concept of just saying that the novel foods could be so detached from what the body needs that the cutoff would be like 2 months before death, something like that. So I'm saying that this is a very weak argument compared to the argument that Chris raised about how complex.
I don't know if you were here for when I said that. I don't know if you were here for when I said, I specifically said don't try to attribute anything Chris said onto what I'm saying. So I agree that what Chris has said is different than what I've said. Now, incidentally, I don't think the cutoff is going to be 2 months near death. That it's an open question as to what. So if whether we can say, okay, well, if we found a novel food that is just as good as the ancestral food to 85, then from 85 to 85 in 1 month, it's going to be better. Or if the actual number is not 85, it's really just 60 versus I think it's going to be more toward the line of probably like 50 or 45 or something. I don't think it's going to be, but that's a different conversation for another time. Point is, there's just going to be some.
I also don't think that anything about ancestral foods automatically follows from this. I mean, food-seeking behaviors or something. I'll grant.
Yeah, food-seeking. I just mean the types of foods.
I'm very annoyed at this conflation between, and I know that because I think maybe you're making it a little bit now, or accidentally veering, or just I'm hearing it because I'm biased by what Nick said earlier. But I think that it's very clear that the foods in the environment were almost never, except maybe in some cases extremely indirectly, selected on to be in the environment because of human health responses to them. They were evolved almost, and there's that changes when you have interactions between behavioral traits and food growing in agriculture and horticulture before that and stuff like that. But you see,
I'm just when I say ancestral diet or whatever, we can have different definitions. I'm just referring to the foods that are the object of our ancestral food-seeking behaviors.
Right. Yeah. And so the sort of like deviation from that is better than that could be ancestral foods in a different mix than what we have food-seeking behaviors for.
Then that would require like some.
So what?
Yeah, that's just going to be an analysis of what you mean by ancestral foods. Then that we could get into that, but that's fine. I'm granting that there could be some conception of ancestral food that's detached from what our food-seeking behaviors ancestrally were. And whether we call that ancestral or not ancestral is just going to be a matter of semantics, and whatever we end up calling that could be better.
All right. So, I mean, just to clarify that we're talking about the composition of the diet versus natural versus artificial foods, right?
We're talking about
a different composition of diet could include artificial foods, but it doesn't have
to. For what? For ancestral foods or for artificial?
For when you posit that we could come up with a diet that is more beneficial in net on post-fertility longevity than an ancestral diet, that's not the same thing as saying that diet could be made up of ancestral foods, just in a different mix of the ones that we seek. Okay, so we agree on that. I think Sar made one point that I'm not quite sure if you addressed, or at least I heard Sar making the point that even if we grant that it's 51-49 in favor of being harmful to, I don't know if Sar would grant that, but let's just grant it anyway. That even if it's 51-49, that post-fertile longevity is disfavored, that's still, there's something different between talking about the proportion of adaptations versus their magnitude. And so it's quite possible that there are, 3% of those 49% are so powerful that they overwhelm the rest. Yeah. And one point that I would make to kind of riff on that, I kind of doubt that that the large proportion of adaptations are all that relevant. Like I feel.
Oh yeah, just to be clear, I've excised
extreme outside.
Yeah, I've excised the neutral ones for simplicity. There's really more than.
No, that's not what I mean. That's not what I mean. I mean that maybe we can posit, like, let's just say we can posit 1,000 different adaptations. I think it's quite possible that 3 or 4 of them might have extremely outsized effects on longevity. I mean, if you just look at the blood lipid example, I mean, you might be able to kind of cover the age of 45 up to 75 with. We used to die of infectious diseases. There was some beneficial effect of high lipoproteins. Now that's carried over into a situation where we don't, and now that's pro-cardiovascular disease. and I think you and I would disagree on certain aspects of lipoprotein's relation to cardiovascular disease, but for the sake of argument, let's just assume that hypo-ApoB lipoproteinemia is the major driver of cardiovascular disease. Suddenly you have one.
Yeah.
Suddenly you have one class of genetic polymorphisms that all basically do the same thing, that you could classify as LDL receptor hypofunction, that are suddenly covering almost all of age 45 to 75 in their relevance. And so you might have like 1,000 other examples of antagonistic pleiotropy.
Yeah, I agree.
This one that covers.
I completely agree. Yes. So I'm not in any. There's nothing. To get to my conditional, it doesn't require any way to assume that there's like a there's homogeneity among the magnitude of the different effects. It's just if you don't know any other information, you apply the principle of indifference, because it could go either way. You can have one. If you know that there's 51-49. So long as you know that, then on the balance of probabilities, the inference is still going to go through. And the fact that there's different magnitudes for different ones, yes, you could certainly get a high magnitude one that ends up on the 49, but you're just more likely to get the high magnitude one that ends up on the 51.
Right, but I mean, I think it's quite possible that after you pass cardiovascular disease and cancer becomes your major cause of death, that you actually get to a point where it might be the case that you have a dietary example of antagonistic pleiotropy and you have genetic examples, and they don't really interact with each other that much. So, for example, I think it's probably the case that the reason cancer becomes such a ubiquitous killer after you make it through the other leading causes of killers is that because there's just antagonistic pleiotropy on genes that don't have dietary interactions that predispose you to probably die of cancer after you didn't die of cardiovascular disease. And I also think that there's a very interesting body of evidence from actually T. Colin Campbell's work, who I mostly disagree with. But T. Colin Campbell did many, many rat experiments that showed that if you have a high protein diet while the rats are being dosed with carcinogens, you protect against cancer because protein promotes carcinogen detoxification and prevents the initiation of precancerous cells. But if you establish the precancerous
once the cancer is there, then it feels it.
Right, and so the problem is how do you derive a dietary inference out of that? On the one hand, I believe in the antagonistic pleiotropy evidence for the predominance of cancer after you don't die of all these other things. And yet, when I look at dietary effects, I don't really see them interacting with those genes so much as just interacting with the competing physiological processes of, for example, protein promoting xenobiotic metabolism, which is anti-cancer, and protein promoting cancer growth, which is pro-cancer. And if you look at the experiments that were done in the animals, they kind of suggest that you're shit out of luck if you're trying to micromanage it, because the only way you can micromanage it is to give a specific dosing schedule of the carcinogen so you have a before and after. And if you're just giving small amounts of a carcinogen with the diet in a continuous way, the protein winds up being protective. And so, just looking at those things, I don't know that you come up with any conclusion except we should probably do trials of low protein diets for people that have established cancers. But I don't know.
Yeah, just to be clear, this is a very, the inference is not a strong inference, nor is it like something that, there's nothing about the inference that claims that, that the antagonistic pleiotropy is mostly diet induced. Or it relates mostly to diets. I'm sure you could find things that are not going to fit into like a diet schema of antagonistic pleiotropy. The inference.
Yeah, but what I'm saying is I just covered the two major killers in the last 4 decades of life and boiled it down to, it's possible it boils down to a couple of principles, and almost all antagonistic pleiotropies quantitatively are irrelevant. And so the quantitative proof of, a survey of different types of these interactions shows that there are more antagonistically pleiotropic ones than not, might be completely irrelevant, because it might be that just the vast bulk of those genes are kind of irrelevant compared to 3 or 4 huge influences on huge.
So for the majority, yeah. I see what you're saying. Yeah. So for most of the causes of death, I think they are subject to antagonistic pleiotropy. Yeah. So,
yeah, but what I'm saying that's all I'm saying. I also think that in fact I just gave you two of the major killers and explained how they were subject to 3 examples of antagonistic pleiotropy. So we're in complete agreement. What I'm saying is that a quantitative analysis of whether the total adaptations are more or less antagonistically pleiotropic versus not might be completely irrelevant because most of them are irrelevant.
Yeah, it could be.
In the grand scheme of practical.
Yeah, no, I agree that that's a possibility. I was just saying that in the face of no information, so I grant that in the face of more information, we can say that, it just turned out to be that it doesn't really matter. All I was saying is that in the face of no information, we would just distribute it on the balance of probabilities with the principle of indifference, and the inference would go through. Now, if we want to say, okay, well, here's more information about heart disease, cancer, chronic lower respiratory disease, stroke, then we would require more of an analysis. Okay, now that we know that the overwhelming majority of causes of deaths are just crammed into these causes, we can look at that with more information. That's fine. And it turns out that I think that if you did an analysis on that, I think you would find that they're not only antagonistically pleiotropic, but many of them are dietarily antagonistically pleiotropic. I think heart disease would fall. We will disagree on that probably on a number of areas, but I think stroke is, by the way, when they list cardiovascular disease, they're not counting stroke deaths. And so stroke deaths actually tick that up a significant degree. And so you really have to want to add that on because that's also going to fall within the dietary antagonistic pleiotropic effect.
I'm sure we could have hours of discussion on CBD and diet, and this turned out to be a lot more than 15 minutes, but it was good. I think it was very valuable to have you on to discuss further. The point is, unless there are other people that want to speak, I think we are kind of at the point to close. So I don't know.
Yeah, just to conclude. Yeah, the point there is just to say that the inference is if without any further information, the fact that there's more, a few of them could be heavy drivers of death would just be irrelevant to the inference. And if we want to add information and to say, now we know that here are the actual causes of death. The response to that is just upon an analysis of those common causes of death, my position would be not only are they antagonistically pleiotropic on by and large, they are dietarily antagonistically pleiotropic on my view. Now that could be disagreed with, but that is my view and I'm happy to defend that. All right, cool.
So just my closing comment, I think, it would probably take us many hours just to talk about that last point. My suspicion is that there are limited dietary antagonistic pleiotropies. I think protein in cancer is a great one that I was just referencing. But part of the reason that I am sort of like against the protein versus longevity, low protein for longevity argument is that protein is generally pro muscle mass, pro bone health, anti-sarcopenia, anti-osteoporosis, neutral towards CVD. We could debate that, but I think it's neutral towards CVD. Pro-cancer after you get cancer, but anti-cancer before you get precancerous lesions. And so I just think that protein winds up being on the net better than lower protein, unless you know you have cancer, in which case that might be different. But I guess in close, my thought is simply that if we take something like cardiovascular disease, and without going into the hours of discussion on the specific points we disagree on, I believe that there are examples of antagonistic pleiotropy there, but they just require selecting differently from among ancestral diets to deal with. And the way that we do that is we take what we've learned from modern science and we juxtapose it on what we've learned from the accumulated body of ancestral wisdom and knowledge, as well as the sort of modern ethnographic body of knowledge about what our ancestors did. And I suspect that you would probably find value just in looking at what different groups of ancestors did at different times in their life and which ones seem to have the best evidence against cardiovascular disease being prominent, for example, in order to further flesh that out. And that would make ancestral health be an extremely valuable heuristic. I would also point out that one of the features of ancestral diets was to give special pre-pregnancy and pre-fertility diets, which sort of means that our ancestors recognized trade-offs between fertility and other values. Now, that doesn't necessarily mean that they consciously were thinking of it as a trade-off between fertility versus longevity. They might have been thinking about it more from fertility versus resources available. But by necessity, they are giving, pre-fertile women a different diet than what older men and women are eating. And so I think that to bring it back to the original question, I think everything that we've discussed is valuable, but it just sheds light on many ways that we could tap into the knowledge base of our ancestors, as well as our knowledge base of our ancestors, to shed more light on the other things we're investigating with science. And
whenever you wrap up, you have a tendency to introduce new points, Chris. Do you notice that?
Well, I guess it was more a reflection on what we talked about rather than a summary of it. And so I think if no one else wants to jump in, I think this is a good place to close. If you want to make a closing remark, I'll give you the last word, Avi.
Yeah. So I'm happy to grant that we could use our knowledge, which is influenced very artificially, to look back at the foods that our ancestors ate and excise some of them and put some of them in from different cultures or whatnot. It would just be a semantic question at that point whether we are calling that an ancestral diet. We could certainly take the foods that our ancestors are eating and use the information we have now gained by technology to back select which ones are promoting for our goals. I grant that, and you probably would find value in doing so. I grant that too. And if you want to call that an ancestral diet, then that's fine. I just want to make an important distinction between that type of ancestral diet and the type of ancestral diet people commonly talk about when they are vaguely referring to the things that their ancestors used to eat, simpliciter. That would be a very important distinction to make, because I don't think that's going to end up with the same health effects. And I'm not sure. I sort of forgot what the other points that you brought up there. But that's just the one thing I wanted to respond to. Right. But other than that, just one thing I want to just the main with heart disease, if heart disease and stroke, which are the main ones I think are going to be antagonistically pleiotropic dietarily. For cancer specifically, yes. So I think protein will decrease risk of cancer until you get it, and then worsen outcomes with cancer. The thing there is just that, generally speaking, as age goes further, if we were to prevent people's death from heart disease, from stroke, the probability of getting cancer, even if you are getting protein, is just going to go higher and higher the older you are, and eventually, and it'll be antagonistically pleiotropic at some age. It may be a later age, but at some age it will. So it's more nuanced than obviously there's nuance there, but I think the same general principle will eventually apply. It may apply at a later age, but there's going to be some crossover at some point.
All right. Thank you, Avi.
Yeah. All right, cool.
So thank you, Avi. Nick is jumping in, and then after Nick, we'll get a quick comment in from Makarand, and then close.
Oh, yeah. I just basically wanted to say that, it doesn't seem like you ultimately disagree in principle with what I said earlier and what Avi has said now. Just because, the inferences that underpin the position, I told you in DMs, they seem trivially true to me. So it would seem kind of weird to reject them, or at least that was my intuition on the subject. So it seems like we largely agree. I think the point of disagreement on your end is more related to the empirical challenges and scientific challenges to obtaining such a diet, which doesn't really have anything to do specifically with the inference itself. It's just hurdles that need to be overcome to attain what the inference is talking about. So it's talking about the inference, is not really talking. It's not discussing and engaging with the inference necessarily to bring up those particular objections. Technically, like Avi said, they're not actually objections. But yeah, I think in terms of the actual position and the underpinning inferences, I think we're all actually largely on the same page, it would seem.
I think my disagreement is both on the path to get there, but also I think that I disagreed with you on something that Avi, I don't think, was taking a position on, which is that we can take the inference about antagonistic pleiotropy specifically to the foods in the environment rather than the food-seeking behaviors. I think that we disagree on that point as well. It looks like Makaran left. He had his hand up, but is no longer there. So I guess we're at the close. So thank you, Avi. Thank you, Nick. Thank you, Sar. Thank you, everyone who came in and listened. And I think we clarified a lot. We didn't agree on everything, but we agree on a lot. And this was a very interesting discussion. So thank you to everyone who participated.
Yeah, no problem.
Thank you. It was an honor.
Take care.